So in section 2.1, we are looking at the beginning of the story on limits. And one of the first things that we really look at is what we call average rate of change, which average rate of change is really just slope. And this is something that you will have looked at in algebra. So the first couple of questions on the homework, numbers 1 and 3, you shouldn't see anything there that you haven't already seen in an algebra class. So, and I gave you an example of that. Basically, in the notes you have another example. I think I worked out number 2. I thought maybe I would look at number 5 just to make sure that, we're all on the same page here. So the instructions tell you to find the average rate of change of the function over the given interval. So we are given the interval between 0 and 2. Now that's an x interval. So what you want to do in order to find the slope is you have to find the points. So we need to plug in 0 and we need to plug in 2. And we need to find those y values so that we have points. So the first thing you're going to want to do on these is go ahead and find your points. So if you plug in 0, we'll have square root of 1, which is 1. And if we plug in 2, it looks like we would have 9, square root of 9. So we get 3. So basically this turns into an algebra question. So our 2 points are 0, 1 and 2, 3. And you want to find the slope between those. So the average rate of change, or the slope, is going to be the change in the y's, so 3 minus 1, over the change in the x's. So the average rate of change on this is 1. That's something that I would expect that everybody should be able to handle. Now, one thing I did want to point out is when you have any graph, so let's say that we have just some graph, okay? If we look at the average rate of change between 2 points, basically what we've done is, let's say that we took this point and this point and we found the average rate of change. So basically we found the slope of that line that would go through those 2 points. This line that is created by connecting 2 points on a graph is called the secant line. And you'll want to know what that is because that's a word that we use quite a bit in calculus. Now, what we do is we start to consider the secant line and we say, well, what happens if I let one of those points move so that it gets really, really close to the other point? So let's envision what would happen if I maybe took this point right here and I started moving it along this graph so that basically it's going to approach this point right here. That's its target. And I want to know what's happening to the slope as that happens. And you have some really good pictures of this in your book that in section 2.1 I would encourage you to look at. But what happens is you get a whole series of secant lines. And then as those points get infinitely close and we end up with our final line, which here might look something kind of like, I don't know, something like this maybe. Or maybe something like that. It depends on exactly the graph, and I didn't have a very good one there. This is kind of a steep slope to look at, but when those points get really, really close and they're basically on top of each other, that secant line that you're left with at that point is called the tangent line. So basically a tangent line is a line that is going to mimic the slope of a graph at a single point. So if you have just any graph and you pick a point on it and you say, well, let's take this one part of that graph